Good evening, everyone. My name is Hayden Hilkemeyer, and my research this semester with Dr. Alicia Cassidy in the Economics Department investigated the impact of tree ordinances. To understand tree ordinances, it's important to understand the economics of trees. Trees are textbook examples of positive externalities, as owning a tree generates myriad benefits for yourself and others. Among these are reduced energy costs from shade, reduced runoff and flood water during storms, increases to air quality, and just general landscaping and privacy values. All in all, these benefits just aren't enjoyed by the property owner, but also by their neighbors and at a neighborhood-wide level. Prior studies on the evaluation of trees prove these benefits, as well as providing details to inform public policy. Most studies value trees based on total coverage or the percentage of land on a lot covered by the tree canopy. These studies present fairly straightforward economic conclusions. First, trees are more valuable where they are more scarce, meaning that a swath of forest in the city is going to be more valuable than in a rural area where it was more common. This just follows simple laws of supply and demand. Second, the older the tree, the more valuable the tree, as the tree is larger and better at providing those positive externalities mentioned on the prior slide. Now, to illustrate those points, consider the map of Indianapolis on the right. Based on these conclusions, the higher income neighborhoods would be towards the top in the darker shades of green, whereas the lower income neighborhoods would be towards the bottom in the lighter shades of green and white. It's also worth noting that within these similar colors, the areas that are more urban would also have greater property values than the areas that are more rural. Third, private properties in the US generally fall short of maximizing their value based on their tree coverage. And that's why it is useful to have policies that increase tree coverage and therefore increase property values. Tree ordinances are a form of this public policy that govern how trees can be planted, maintained, and removed in a municipality. Now, the way many of these ordinances define if a tree is affected by the ordinance is by measuring the diameter of the tree at 4.5 feet off the ground, which is known as the diameter at breast height, or DBH. There are 3 different types of ordinances that exist, each for different purposes. Street ordinances define how trees are maintained in the public right-of-way, such as on sidewalks, on the side of roads, in parking lots, and in parks. View ordinances exist to solve disputes between 2 property owners when a tree on one person's property is thought to negatively impact the property value of the other person by obstructing a view. And these first 2 ordinances are pretty ubiquitous in municipal codes. What's less prevalent are heritage ordinances or protective ordinances, which protect trees of particular historical or biological importance. These ordinances apply to all private property, not just public property or view disputes. In this research, the city of Austin, Texas serves as the case study for protected tree ordinances. Austin's own heritage tree ordinance protects trees endemic to the area that are especially large and old. Austin also has one of the oldest protective tree ordinances in the country, and it really serves as a model for the expansion of these ordinances nationwide. Nonetheless, exceptions can be made to the ordinance, as not all situations are the same. Austin contains an estimated 30 million plus trees, but less than 1% fall under the ordinance. Specifically, those trees are the oldest and the largest in the city and are significant to their communities. For this reason, Austin's tree ordinance is great for increasing property value. It specifically applies the 2 conclusions we mentioned prior that most increase property value for property owners, such as there being larger, older trees, and also trees being present in the city limits where they are most valuable. However, there are also negative effects of imposing upon property owners. The added costs and bureaucratic hassle associated with obtaining a variance, a permit, or holding a public hearing are drawbacks, not to mention a hefty $2,000 fine for illegal action. Furthermore, just by constraining the choices of property owners in the future as to what decisions they can make for trees on their own property, a negative option value is generated for the owner of the tree. Now, at this point in time, you might be wondering, what is an option value? In essence, an option value is what an individual is willing to pay to preserve a public good for future use. A prime example of this is national parks. Whether you have ever been or ever will go to a national park, there is undoubtedly some amount of money you would pay today just to have the option to go to a national park in the future. This means they have a positive option value. To say then that Austin's tree ordinance generates a negative option value means that if you were to ask tree owners the same question about their trees, they would have to be paid money to want to maintain that tree for future use. This is due to the restriction of their future choices. Now, quantifying this option value essentially comes down to the difference between typical property value added per tree based on literature and estimated property value added per tree in Austin under this ordinance. The way tree values are calculated is through hedonic analysis, and hedonic analysis is one of the most common methods for calculating real estate value. Homes are heterogeneous goods and they're highly variable, so calculating their value is difficult. And what hedonic analysis does is it samples homes across one neighborhood in order to make sure that real estate fluctuates in the most consistent way possible to increase accuracy. It's also a demand-driven method, meaning it relies on existent sales history for real estate, and this data is available in government databases, and given its size, the housing market is pretty reliable and efficient. After sampling data, a multivariate regression is constructed, which divides homes into structural characteristics like bedrooms and bathrooms, location characteristics such as road quality and school district, and environmental characteristics like air quality and distance to the nearest park. This whole regression relies on the fact that these characteristics are what determine the value of homes. And these regressions are typically made in Stata, which is a programming language used by economists for hedonic analysis. Now, the coefficients to determine these variables assess how a single unit change of that variable will affect the real estate value in that neighborhood, such as how being a mile closer to the nearest park increases value. To construct a model for Austin neighborhoods, besides using some of those variables we previously mentioned for hedonic analysis in any sort of model, it's also important to account for different tree species, different tree sizes, and also historic changes to the ordinance over time. In defining those variables, the first change lies in the ordinance history. Established in 1983, the ordinance first deemed trees over 19 inches in dBH as protected. An addendum in 2010 added more restrictions, stating that trees over 24 inches were now heritage trees. And this will break the data into two distinct time periods for constructing the model. Secondly, there are 9 specific species of trees addressed in the ordinance, and also all oak trees are covered, which creates at least 10 different variables for tree species. Third, different cutoffs for dBH group trees into 3 general size categories, which might produce interesting effects around each cutoff. Based on prior research on tree value and option value, I hypothesized that option value will be increasingly negative after each cutoff of dBH. This is due to increasing inconvenience and cost to property owners. And it's important to note that the negative option value generated should never exceed the actual value of the tree, as trees have never been known to generate option values unless they are diseased or dead, in which case the ordinance doesn't apply. Next steps for this project are contacting Austin realtors to get their data and select neighborhoods. And at this point, I'd be happy to field questions.
Hayden, in the absence of heritage tree ordinance, what other tools can cities use to preserve the economic benefits of their trees?
Sure. So tree ordinances, like heritage tree ordinances, usually only affect private property. What they don't affect as much is commercial properties. So a different ordinance present in Austin, for example, maintains that if for commercial development trees are being cut down, there has to be a 1-to-1 ratio of replacement based on the DBH. So if you were going to cut down a tree that was 10 inches in diameter to put in a supermarket or something like that, you would have to plant 5 trees 2 inches in DBH or 10 trees 1 inch in DBH in order to make up for that. Now, this presents some difficulties because trees that are smaller don't generate the same externalities like we mentioned because those increase with height. So there's a sort of lag in investment of planting these newer trees and actually benefiting from that effect.
How exactly do you place a dollar value on a tree?
So, like I mentioned with homes, trees are also heterogeneous goods. So there's not any one variable you can look at and say, this is what makes this tree worth this much money. So, like a home, there's actually ways that arborists, which are people who assess the value of trees, break down their value. So, for example, they might break it down into different categories like a hedonic analysis where they're talking about, okay, how close is the tree to the house and how large is the tree and how much square footage of canopy cover does it provide and what species of the tree it is. And there are all of these variables that go into this analysis.
That's all the time that we have for today. Congratulations, Hayden, and thank you very much for your interesting presentation.